Welcome to aminacademy.com. Let us discuss about mathematical formulae and that operations with matrices. First, what is equal matrix? Two matrices are said to be equal if both the matrices are the same order. That is n into n or n into m. Another one is also n into m. They have the same order of rows and columns. That is AMN is equal to BMN. That is matrix A equal M1 and matrix B also in terms of M1. If the elements of the first matrix are equal to the corresponding elements of the second matrix, that is matrix of Aij is equal to Bij. That is, look at here, this is exactly equal matrices because here number of rows and number of columns are equal in respect to matrix B. Then look at the elements also equal. So it is exactly two equal matrices. Next one, addition and subtraction of matrices. When we can only add or subtract matrices if their dimensions are the same, that is m into n order. Both are m into n order. To add matrices, we simply add the corresponding matrices elements together. To subtract matrices, we simply subtract the corresponding matrices elements together. Not only we add and subtract matrices, but we can solve matrices equations as well. Here, look at here. These two matrices we are adding. First matrix is ADG, BEH, CFI. Here, second matrix is JMP, KNQ, LOR. Look at this. Both adding means respective terms are added here. That is A plus J, D plus M, like continuing all elements. Next is scalar multiplication with matrices. The matrix scalar multiplication is the process of multiplying a matrix by a scalar. Let A be a matrix and K be a scalar, that real number. Then Ka is the result of the matrix scalar multiplication. To find Ka, we just multiply every elements of A by K. Look at here. This matrix A is given and scalar K, we are multiplying with scalar K. Each and every elements are multiplied by K. Next, multiplication of two matrices. Matrix multiplication is a binary operation whose output is also a matrix when two matrices are multiplied. In linear algebra, the multiplication of matrix is possible only when the matrices are compatible, that is, to be multiplied. In general, matrix multiplication, unlike arithmetic multiplication, is not commutative. That is, matrix multiplication is not always commutative, which means the multiplication of matrix A and B gives AB cannot be equal to BA. That is, we can say AB, that is matrices multiplication of A and B, is not equal to B and A. Therefore, the order of the multiplication for the multiplication of matrix is important. Two matrices A and B are said to be compatible if the number of columns in A is equal to the number of rows in B. That means the A is a matrix of order Mn, that B is a matrix order Np, then we can say the matrices A and B are compatible. Look at here, matrix A have Mn order, matrix B have Np order. Look at here, Mn, then matrix B is Np. This must be equal. That is, number of columns in matrix 1 must be equal to number of rows in second matrix. Then result matrix is M and P. Here, next one, transpose of a matrix. A transpose of a matrix is found by interchanging its row into column or column into rows. The transpose of the matrix is denoted by the letter T in the subscript of the given matrix. Look at here. Here, Matrix A is A, B, C, D, E, F, 2 into 3 order. AT, that is transpose of this matrix A, is rows become column, column becomes rows. Here AD come here, BE here, CF here. That is, look at here, this transpose. A transpose is AT. In this, next one, orthogonal matrix. What is orthogonal matrix? An orthogonal matrix is a square matrix if and only if its transpose is same as the inverse. That means AT must be equal A minus 1, A power minus 1. That is AT is equal to A inverse, where A power T is the transpose of matrix A and A inverse is the inverse of the matrix A. From this definition, we can derive another definition of an orthogonal matrix. That let us see how. AT equal A power minus 1, that is pre-multiplied by A on both sides. That is A multiplied with AT must be equal AT is multiplied by A pre-multiplied and A inverse is multiplied by A, which is equal identity matrix I. Look at here, a square matrix A is orthogonal if AT is equal to A minus 1, that is inverse matrix. Next one, adjoint matrix. The adjoint of a matrix is one of the easiest methods to use to calculate the inverse of the matrix. It can be called adjacent matrix also, is another term used to refer the adjoint matrix in linear algebra. An adjacent matrix is especially useful in application where an inverse matrix cannot be used directly. The adjoint matrix of a matrix is obtained by taking the transpose of two cofactor elements of the given matrix. Look at here. Here, adj can be written as matrix A power T. That means row become column, column becomes row. Next one, trace of a matrix. What is that? Trace of matrix. The trace of the matrix is a fundamental concept in linear algebra, playing a critical role in various mathematical and applied disciplines. Defined as the sum of the diagonal elements of a square matrix, the trace provides a significant insight into the properties of matrices and their applications. Look at here, this matrix A is a square matrix. This diagonal, if we add the elements of this diagonal, must be equal to trace of that matrix. Now, next one, inverse of a matrix. The inverse of a matrix is a matrix which is multiplication of the given matrix gives the multiplicative identity. That is ICOM. For a square matrix A, the inverse is A inverse A minus 1 and A into A inverse is A inverse into A equal to I, where I is the identity matrix. Look at here. Here matrix A in 2 into 2 order is A, B, C, D. The inverse of this matrix can be written as A inverse, that is equal A, B, C, D power minus 1, which is equal to 1 by determinant. Determinant is AD by BC, that is divided, and into change the first diagonal, interchange the diagonal element of the prime diagonal, that is D becomes here, A become this, and other change the sign of the other elements, that is B become minus B, C become minus C. This is the easiest way to find the inverse of 2 into 2 matrix. If it is a 3 into 3 matrix, we have to calculate adjoint A by, that is A inverse, is generally in square matrix adjoint of A over determinant of A. This is the formula for finding inverse of square matrix. Next one, eigenvectors. The eigenvector is a vector that is associated with a set of linear equations. The eigenvector of a matrix is also known as a latent vector, proper vector, or a characteristic vector. These are defined in the reference of a square matrix. Look at here. Suppose this is a n into n matrix, that is A into eigenvector x vector is equal to lambda into x vector, where this lambda is called eigenvalue and eigenvector is x vector. One more here, that is, look at here, that we can say determinant of vector A matrix minus lambda I matrix, I into matrix is must be equal to 0 for this condition. This is a correct lambda satisfy the characteristics equations. Now next one, in general matrix, look at here. In general, A product of AB inverse must be equal to B inverse, that product of A inverse, that is interchanged. So far we discussed about the different types of matrices. That is not different types, it's different operations of the matrix, that is A inverse, product of two matrices, addition of two matrices, subtraction of two matrices, eigenvalue, eigenvectors, like we discussed here. We have done. Please subscribe our YouTube channel.